So I'm going to talk about quadratic forms. So the quadratic form that this topic is all about, it's actually a rational function. Okay, look at this. It's a rational function, but the function in the denominator is a function that is quadratic in form. Well, the simplest function that is quadratic in form is, of course, a degree 2 function. Okay, and there's a lot of integration formulas for functions that show a quadratic form. This is just a few. Okay, this is just a few. And this is what I saw from the net. Usually these are listed. Even this is only one half of the tables that I see in the back pages of books in integral calculus. No universities in the world will explain to you why each of these integration formula came to be. So usually the instructor in integral calculus, he will explain one formula. Okay, he will derive one or two formula, and then the rest, sometimes they just give it as a problem set. And I remember my experience with my comprehensive exam. I took my comprehensive exam last May. I did pass it. I had to get the integral of a function that looked like this. Okay, this function, it's ubiquitous in statistics, especially in higher stat. And as I recall it, I had to do the integration in one subject, mathematical physics. And I think I got it. I got it right. Okay, so in this lecture, in this lesson, I will no longer show to you how the integral formula came to be. Okay, I will go straight to the formula. So the reason why we call this quadratic forms, well, these are actually rational functions. But the quadratic form that we refer to here are the functions in the denominator, okay? So I will go straight to the formula. And if you want to verify if this is so, all you have to do is get the derivative of this function, okay? So if that is your f of x, get the derivative of f of x, okay? And that should give you 1 over, x squared minus a. Okay, that is our definition of the derivative and of the integral. Okay, so if you want to check it, do it. Get the derivative of 1 over 2a times ln of this, and get the derivative of 1 over a times arctan of u over a. I will go straight into how do you use this formula. But you know what? Before you can use the formula, this is actually the critical skill that you must have. It's about completing the square. Okay, let us review completing the square, because your functions in the denominator will not always look like that. So you have to do something so that the function in the denominator begins to look like this. Okay, so that is the point. And so the critical skill here is completing the square. Let us write this in such a way that it is comparable to your functions in the denominator of these functions. Okay, so how do we complete the square? What we do is we pay attention to the coefficient of the term that is degree 1 term. We divide it by 2 and then we square it. Okay, we divide it by 2. Negative 4 divided by 2 is negative 2. And then you square it and then you add it. And then, of course, you must subtract it at the same time. Okay, if you don't subtract it, you are changing the expression, okay, or you're changing the function. Okay, so that's the reason why you must add and subtract the same quantity at the same time, so that you are not changing the function you are working on. And so this one can now be written as the square of x minus 2 minus 4. Okay, so this one is quite comparable now. So this expression now is comparable to your function here in the denominator. Okay, u is x minus 2, a squared is 4. Okay, so this is a squared, and so the value of a is 2. Okay, let's do one more completing the square. Okay, so let us produce something. Okay, let us rewrite this so that it becomes comparable to this. U squared plus A squared. Again, what you do is you divide 6 by 2, you square it, and then you add it. Now you must subtract it again so that you are not changing the function that you are working on, okay? It becomes you add 3 squared and then you subtract 3 squared again. And so it is equal to the square of x plus 3, okay? Plus 100 minus 9 is 91. So this is u squared, okay? U and then squared plus, this is a squared. This is a squared. So a squared is equal to 91, which means that a is equal to the square root of 91. So once you have transformed a function in this way, in this form, then you are now ready to apply your integration formula. Here, a is equal to 3. A is equal to 3. So the integral of 1 over x squared minus 3 squared dx is equal to, let us bring back our integration formula. Look at that. So a is equal to 3. So it's equal to 1 over 2 times 3. 1 over 6 times ln of x minus 3 over x plus 3 plus c. How about this? So this one requires completing the square. The integral of 1 over x squared minus 4x dx. So let us work on x squared minus 4x. So again, you call this quadratic in forms not because the function is a quadratic function or a function that is truly quadratic in form. The quadratic forms here are the functions in the denominator, okay? Okay, so let us work on the denominator. So what we do here is we divide this, the coefficient of the term that is degree 1, okay? We divide this by 2, we square it, okay? We add it. We subtract it at the same time. And so you can now write this as the square of x minus 2 minus 4, okay? So the value of a here is 2. A squared is 4, but a is equal to 2. Okay, so be careful. It's almost comparable, almost like your integral formula. So it's going to be 1 over 2 times a, but a is 2. So it becomes 1 over 4. Times ln, okay, be careful with this. So times ln of x minus 2 minus a, which is also 2. All over x minus 2. This is your u. Okay, look at that. U plus 2. Okay, so if you were to simplify this, this becomes x minus 4, which is that. And then this one is equal to x minus 2 plus 2. That is just equal to x. So this one really requires careful observation and careful writing, okay? You need that. So this is our answer. Okay, the integral of 1 over x squared minus 4x is equal to this. 1 over 4 times ln of the absolute value of x minus 4 over x plus c. How about this? Now be careful, okay? It doesn't mean that every time you see a rational function that has a denominator that is quadratic in form, you have to do this integral formula. So you have to be careful. Well, this one is in fact can be done by using the first major method that we did, which is the substitution method. Let u be equal to x squared minus 1. du is equal to, okay, du is equal to 2 times x dx. So x dx, look at this, x dx is 1/2 times du. So we can now write our function in this way. This function or this integral is equal to 1/2, okay, 1/2 times the integral of 1 over u du, and that is equal to 1/2 times ln of the absolute value of u, okay, and then you just replace u by x squared minus 1 plus c. Obtain the integral of 1 over x squared plus 9 times dx. Okay. I kind of have some preference for some particular functions, and this is one of the functions that I like. Okay. 1 over x squared plus 9. It's like it has a symmetry about it. This is a square. This is a square. What I like most about this is the integral is something like this. We don't see the arctan function often. We don't see the inverse trigonometric functions often, which is why when I see this, oh, that is kind of nice and it looks kind of beautiful for me. Okay, so you just have to be careful here. Okay, so here 1 over x squared plus 9, this is your u squared. So here a squared is equal to 9, so which means a is equal to 3. And so it's going to be equal to 1 over a, 1 over 3 times arctan of u over a, or x over 3 plus c. How about this? The integral of 1 over x squared plus 6x plus 18 dx. When the terms are separated by the plus sign or the operation plus, the direction to go is to go here because this is the sum of two squares. This one is the difference of two squares. So right away, okay, you have some hints that this will bring you the arctan function, okay? Again, we complete the square. You divide x by 2, you add it and subtract it at the same time. This is now equal to this. This whole 3 terms is equal to the square of x plus 3, and 18 minus 9 is 9. Okay? So let us bring back our integration formula. So this is equal to 1 over a, that's 1/3, times arctan of u over a. So u is x plus 3 and a is again 3. And then of course plus c. How about this? You know right away that this one ought to bring you to your arctan function. Okay, so how shall we do it? So this is what I will do. I will factor out 5. I will factor out 5 from the denominator, from the whole function in the denominator. So that means this one becomes 1/5. If you are not sure about the factoring, all you have to do is to multiply 1/5 back to your function. So this becomes 5x squared, and then 5 times 1 over 5 is just 1. And that is the function we are working on. So right away, it is now comparable to this, the sum of two squares, and this should give you your arctan function. So it is equal to, again, okay, 1 over a. So by the way, what is a here? Okay, so this is a squared. This is a squared, 1 over 5. So that means a is equal to the square root of 1 over square root of 5. Okay? So a is equal to 1 over square root of 5. So this one is equal to 1/5. Okay, so we will just copy it. Times 1 over a. So 1 over square root of 5. This is just equal to square root of 5. Okay, so that's the reason why you have that. Square root of 5. Times the arctan of u over a. So x over a, and a is again 1 over square root of 5. So this is equal to the square root of 5 times x. When you are already in this part, you need some careful thinking, careful observation, and careful writing. Let us get the integral of 1 over 2x squared minus 10 plus x dx. What we do? We factor out 2. And again, at the same time, okay, since this one is subtraction, our goal is to get here, to get a function where the denominator is a sum of 2 squares. Okay, we factor out 2 from the denominator, so it's like factoring out 1/2. So this becomes x squared minus 5x. Okay, x squared minus 5x. We divide this by 2. We square it. We square, we add it, and we subtract it at the same time. So this one is the square now of a binomial. Okay, it's equal to x minus 5 over 2, all of that squared, minus 25 over 4. When you are already in this part, this is your u, and this is your a squared, which means that a is equal to 5 over 2. Okay? So it is equal to 1/2, okay, 1/2, times 1 over a, 1 over 2a, I mean 1 over 2a, so 1 over 2a, but our a is 5 over 2. 2 divided by 2 is 1. So it becomes 1/2 times 1 over 5. Okay, so this 1/2 here is this. So 1/2 times 1 over 5 times ln of, okay, x minus 5 over 2 minus a, and a is 5 over 2. All over, okay, ln, all over x minus 5 over 2 plus 5 over 2. This one is equal to x minus 10 over 2, and that is equal to x minus 5, okay? X minus 10 over 2, x minus 5, and this one is just equal to x. And then, of course, plus c.